Okay, exciting times. We're on the second paper, okay? This is January 21, and it is 2FR. So we're going to do a similar approach to the last one. I'm only going to cover the foundation paper questions on this video, and the ones that cross over, the ones that are in the higher paper, I'm going to do on the higher video, okay? So we're just going to focus on the foundation skills for this video. Again, here we have our formula sheet. This is at the front of every exam paper you do. Remember, you have trapezium, volume, surface area. So if we ever have questions with trapeziums, volumes, or surface areas, you should always come and look at this page. Right, are we ready? Question 1. Let's read the question and see what is happening. Here are 5 discs. Each disc has a number on it. These 5 discs are arranged to make the number 41283. 41,283. So, show how all 5 discs can be arranged to make the smallest number. How are we going to make the smallest number? We are going to put the smallest digits first because they have the biggest weight. Because we know that this is the 10,000 column, we want this to be the smallest. So what's the smallest one we have? 1. What's the next smallest one? 2. The next one? 3. The next one? 4. And the last one? 8. Perfect. We've now made the smallest number. Part B says, show how all 5 discs can be arranged to make the largest even number. What do we know about even numbers? They will end in an even number, so either a 4, a 2, or an 8. So this number on the end has to be even, because then we'll be able to divide it by 2 and won't have a remainder, okay? So, however, it also wants the largest even number. And what did we just say? If the smallest number, we have to put the smallest number first. The largest number, we're going to have to put the largest number first. So let's go. So the largest number is 8. Okay, that's all right, because I've still got a few even numbers left that I could use for the end number, can't I? What's the next largest number? 4. That's okay, because I still have an even number left that I could use for the end. Which number is going to have to go on the end now? 2. That's going to have to go there. Now, what's the next largest? 3 is left. And then 1. So that's how we have now found the largest even number by a process of elimination. This is the only answer. If you have a different answer, okay, you might have 83,124. That's less than 84,000, so it's wrong. Okay, which of the 5 numbers on the disc are a factor of 21? So which of the numbers on the discs are a factor of 21? What's a factor? A number that's easily goes into 21 when we divide it. So let's see. It is 3. 3 can go into 21. How many times? 7 times. So 3 is a factor. 21 can be written as 3 times 7. 4 does not go into 21. 1 does, however we want. We could write 1 because 1 and 21 are still factors of. So the only factors of 21, okay, are 1 and 3. Okay, next. Part D, the 5 numbers on the disc, which ones are prime? What do we know about prime numbers? Prime numbers have exactly 2 factors. Exactly 2 factors. So the number 4, how many factors does 4 have? 1, 4, 2. It has 3 factors. Is it prime? No. And there's a fun fact about prime factors. There's only one prime number in the world that's even. And it is the number 2. Because the number 2 is just 1 and 2. How about the number 1? Is that a prime number? How many factors does 1 have? 1. What does prime factors have to have? Exactly 2 factors. So is 1 a prime number? No. Is 2 a prime number? Yes, it has 2 factors, 1 and 2. Is 3 a prime number? Yes. How do I make the number 3? 1 times 3. 4 is not a prime number because we figured out it has 3 factors, but also the only even prime number is 2. So 4 and 8 are automatically crossed out. So the only prime numbers are 2 and 3. So question 2. The pictogram shows information about the number of emails Sophie received on each of 4 days. Now, with a pictogram, sometimes they give us a key, sometimes they tell us to find the key. In this question, they've given us a key. So what does 1 envelope mean? 4 emails. Okay? So, if I was to draw this, what does that mean? 2 emails, because it's half of the picture, isn't it? Okay, this is our guide. So, on which of Monday, Tuesday, Wednesday or Thursday did Sophie receive the least number of emails? Which one has the least pictures? Wednesday. We didn't even have to work that out. We can just look at the pictures. Brilliant. It says find the ratio of the number of emails Sophie received on Monday to the number of emails Sophie received on Tuesday. Give your ratio in its simplest form. How many did she receive on Monday? 4, 8, 12, 16. Because this represents 4. And we have got 4 lots of 4, which is 16. So we know Monday is 16 emails. How about on Tuesday? 4, 8. And then we have half of one of these. Half of 4 is 2. So 4 plus 4 plus 2. 10. Hey, is this a ratio in its simplest form? No. What could I do? I could divide by 2. And then I'm going to get 8, 5. Can I divide that again? No, so 8, 5 is simplest form. Because 8 and 5 do not share a common factor. So we can't make it any simpler. Brilliant. It says on Friday, Sophie received 14 emails. Show this information on the pictogram. Okay, 14. How can I make 14 with 4s? What am I going to do? 14. So what's this? 4, 8, 12. If I draw another one, that's going to get me 16. So I'm going to have to draw half of one of these, aren't I? There we go. 12. Perfect. Then it says on Friday, 6 of the 14 emails Sophie received were from Kamal. Write 6 as a fraction of 14. Write it in your simplest form. So this is 6 out of 14. Is this simplified? How could we simplify this, making it equivalent? We could divide the numerator and the denominator both by 2, which gives me 3 over 7. Perfect. Okay, the question carries on. It says on Friday, Sophie received 14 emails. On Saturday, she received 11 emails. And on Sunday, she received 6 emails. Draw a bar chart to show the number of emails Sophie received on Friday, Saturday and Sunday. So 14, 11 and 6. Which is the highest number? 14. So we know that this has got to go up to 14. 1, 2, 3, 4, 5, 6, 7, 8. Does that go up to 14? So my scale can't be 1 anymore. What could it be? 2. So 2, 4, 6, 8, 10, 12, 14, 16. Now, we're all using a pencil, aren't we? Oh, no, we're not. Please get your pencils out now. So, then we're going to need a ruler. Now, with bar charts, we should have equal gaps in the middle. Friday is 14. So, on a Friday, we know we're going to go up to 14. Saturday is 11. Now, 11 is in between 10 and 12. So, I need to make sure it's exactly halfway between 10 and 12. And on Sunday, we have 6. Now, I've put them all... Oh, that's not quite 6, is it? I've done all of my vertical lines first. Now I'm going to do my horizontal. There we go. So, Friday was 14. Saturday is 11. Okay. Oh, right there. Oh, it's harder than it looks on an iPad. And then Sunday is 6. And we can see we have equally spaced gaps in between. This is exactly how your bar chart should look. Okay, question 3. Complete the following estimates by writing a suitable metric unit on each of the dotted lines. The distance from Paris to Berlin is about 1,000 what? 1,000? Is it going to be 1,000 centimetres from Paris to Berlin? No. What's going to be a suitable thing? Miles or kilometres. A bucket holds about what? 5 litres. So 5 litres of water. Now, I know some people are going to do American, some English spelling, okay? Then, the area of the screen of a mobile phone is about 90... So, this is going to be centimetres squared. Because if you think, like, we're looking at my iPhone now, my iPhone is probably about 7 centimetres long. Okay? Now, it then says, write down an estimate for the height of a bedroom door in a house using suitable metric units. So, a height is probably about 2 metres, I reckon, roughly. So, 2 metres. Okay, now I've just looked at the mark scheme and they're only accepting kilometres. Okay, so make sure you put miles or kilometres. Oh, you know why they don't accept miles, don't you? Let's read the question. It wants metric units, and miles is not metric, miles is imperial. Okay, always double check we've read the question. This is why we do our sensible check, isn't it? We sensibly read the question and check. Question 4. Oh, I love these questions. So, here are 3 3D shapes, A, B and C. Write down the mathematical name for each of these 3D shapes. Now, the first one looks like a ball. However, it's not a ball, it's called a sphere. P-H-E-R-E, sphere. The next one, part B, is a cone. If you think about it, it's an upside down ice cream cone. Yeah. And then the last one is called a prism. A prism. Now, some people might have put hexagonal prism, and that is also accepted, or hexagon prism, because our face here is a hexagon, because it has 6 sides, okay? How many faces does shape C have? Well, let's count the faces. This is the faces. We have the front, we have the back. Then we have our 6 sides. So how many is that all together? 8. How many vertices does shape C have? So these are the corners. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and we can do that by just writing, working it all out. Okay, here we go. Here is a solid prism made from bricks. The bricks are identical triangular prisms. The volume is 54 centimetres squared. Work out the volume of each brick. How many bricks has it taken to make this shape? Now, looking at this, we can see the front and the side. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, obviously, it takes 9 for this. But then it also, because it's twice as thick, 9 times 2 is 18. So, 18 bricks equal 54. How am I going to find what one brick is? 54 divided 18, which is in fact 3. So that means one brick is 3 centimetres cubed. Now our sensible check. 3 lots of 18, does that give us 54? Does 3 times 18 give me 54? Yes, it does, so I know I'm right. Question 5. So here we go. The table shows the temperature recorded in Amsterdam at 6 a.m. on each of the 5 days. What is the range of temperatures in the table? So what does range mean? The highest temperature minus the lowest. So what is the highest temperature here? The highest temperature is 4, because that's the warmest, isn't it? So the highest is 4. Minus the lowest, what's the coldest temperature? Minus 6. What's 4 minus 6? 10. So the range of temperatures is 10 degrees. We could also see this if we were to draw. Imagine, I've got a great idea. Voila, the great idea. We have a thermometer. Imagine this was 0. Then this is 1, 2, 3, 4. Okay, that was the highest, wasn't it? What was the lowest? Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Whenever I'm looking to understand negative numbers, I always go back to this thermometer. It's really good. If you think, from 4 to negative 6, how many degrees has it dropped? It's 10 degrees as difference. This is our range. The median means the middle. Once in order. We have to put this in order first. We can either do coldest to hottest or hottest to coldest. It won't matter because the middle will be the middle. What do you want to do? Coldest to hottest. Great idea. So what's the coldest month? Minus 6. Then minus 5. Then minus 1. Then 4. And that's right, isn't it? So the median is the middle. And what is in the middle? Yeah, because minus 6 and 4, minus 5 and 3. So in the middle is minus 1. So that's the medium temperature. Great question. Imagine there was no middle. Imagine there was a 5 here. And this was no longer our middle. Okay? It would be 6, minus 6 and 5, minus 5 and 4. And then in the middle, we have these two numbers. So what we do is we then find the middle of minus 1 and 3. Now, sometimes to do this, I just like to draw this again. Minus 1 to 3 is minus 1, 0, 1, 2, 3. What's in the middle of minus 1 and 3? 1. So that would then be our median, okay? Or let's say, though, we were finding the median between minus 1 and 2, for example. Okay? Minus 1. What's in between 0 and 1? 0.5. So that's how we work it out. We just work out the middle. That's literally what we're doing. And sometimes we get the number straight away, like we did. Sometimes if it's in between two numbers, we just work out the middle of those two numbers. And everyone can draw a number line, can't we? So we can't always find it. Well done. Then it says, what percentage of the temperatures in the table are lower than 0 degrees? How many of the temperatures are lower than 0? What's colder than 0? The -1, the -5, the -6, isn't it? So 3 are colder than 0 out of how many temperatures altogether? 5. What is 3 over 5 as a percentage? It's not 75%. Okay, we shouldn't be guessing. Let's convert it to a decimal first. Yeah? 3 over 5 is 0.6. 0.6 is 60%. Now, how have we done that? Now, if you want, we can do 3 over 5. A percent is always out of 100, isn't it? 5 times what is 100? 20. So if I multiplied my fraction by 20 over 20, 5 times 20 of my denominators is 100. 3 times 20 is 60. So this is another way we can look at it. There's many different ways for this one. We have to have an understanding of decimals, percentages, fractions. It then says, on Saturday of the same week, the temperature recorded in Amsterdam at 6 a.m. was 8 degrees. So on Saturday, it was 8 degrees. God, that really picked up, didn't it? It got warm. Oh no, sorry. Oh, see, this is something, right, that happens. Did I read the whole sentence? No. Let's read the whole sentence. It was 8 degrees higher than Friday. So it wasn't 8 degrees, was it? We increased by 8 degrees. We added 8 degrees. So if I was at -6 and I added 8, where do I get to? 2 degrees. So actually on Saturday it was 2 degrees. Make sure you read the question fully before we jump ahead. Because I nearly made a huge mistake then, didn't I? And that was easy to do, wasn't it? Because it did look like that could have finished the sentence. However, we just need to read again. Okay then, let's take a look at question 6. So, there's a lot to digest in here. I want you to read question 6. They always have one of these on the exam. We need to really know how to answer these types of questions. So, Mikhail has 1,200 grams of cake mixture. He's going to make 3 cakes, cake A, cake B and cake C. 4/15 of the weight of the cake mixture will be used to make cake A. Right, so if we have 1,200 grams in total, 4/15 is going to be used for cake A, isn't it? So what do I need to split my bar into to figure out 4/15? I need to split it into 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. What happens if I haven't drawn enough? 14, 15. There we go. It's easy to do. So what is 1,200 divided by 15? 80. So we know technically each one's worth 80. How many? So 4/15 is how many 80s? 4 80s. So 4 times 80 is 320. Okay. So I know that 320 is going to be used for cake A, isn't it? 320 is used for how much? Cake A. How much is left for cake? This is cake A. How much is left for cake B and C? Cake B and C is whatever's left over, isn't it? So 1,200 minus 320 is going to give me 880, right? And that's what's left for cake B and C. But we don't know really what we have to do now. So let's carry on reading. The rest of the cake mixture will be used to make B and C, but we don't know if it's half each or not. We've got to keep reading. The weight of the cake mixture used to make cake B and the mixture used to make cake C will be in the ratio 3:8. So if it's in the ratio 3:8, 3 parts is for B, and how many is for C? 8. Now you can see I'm using a different approach here. You can still use the bar model, I'm just drawing pictures. How many boxes do I have all together here? 11. So that means 11 boxes equals 880, doesn't it? This equals 880. So how am I going to find one box? I'm going to do 880 and divide it by 11. What do I get? This is going to give me 80. So, there is still 80, okay? But B has 3 80s. So how many grams is B? 3 times 80 is 240. C has how many? C does not have 11. C has 8. What's 8 80s? 8 times 80 is 640. So now we know A is 320, B is 240, C is 640. Now what should I do as a clever mathematician to check that I'm right? How many grams did he have altogether? So let's check. Does 320 plus 240 plus 640 equal 1,200? I need to check that's what it equals, doesn't it? So 560. Yes, 1,160. Yes, it does. I know I'm right. I can move on to the next question. Well done. Okay, question 7. So here are 5 times in a 24-hour clock. Write down of the letter of the nearest time 6 p.m. So what do we know about 6 p.m.? 6 p.m. in the 24-hour clock is 1800. So which one is closest to 1800? We know it is D. So there we have D. It says work out the difference in hours and minutes between A and E. So A is 11:53. E is 16:45. Or we know that's also 4:45 p.m. Now when I'm working out this, I like to think about what's happening here. So 11:53 to the nearest hour is plus 7 minutes, isn't it? If we plus 7 minutes, we're going to get to 12 o'clock. Now, if I need to get to 16:45 or 4:45 p.m., I know if I add 4 hours, I get to 4 p.m. And then I just need to add 45 minutes. So you can draw it like this if you want, if you find it easier. Sometimes I find it easier to lay everything out. So that means I have 4 hours, 45 minutes plus 7 minutes is 4 hours and 52 minutes. Okay then, next part of the question. Francisco uses the rule below to find the time in minutes to cook a chicken in his oven. Number of minutes to cook a chicken, multiply the weight by of the chicken by 40, then add 15. The clock on Francois' oven shows time B. Okay, so it's 15:20 currently, which is 3:20 p.m. Francois starts cooking the chicken at this time. He stops cooking the chicken when the clock is on E. Okay, so we already know that E is 4:45 p.m. Work out the weight of the chicken. Okay, so how long, first of all, is 3:20 to 4:45? So some of you might say, right, 3:20 to 4 p.m. is 40 minutes. And then 4 to 4:45 is 45 minutes, okay? You might do it a slightly different way, where you could also say, this is also okay, 3:20 to 4:20 is 1 hour. And then you know that 4:20 to 4:45 is 25 minutes.
So we know the total time for this chicken is 1 hour, 25 minutes, or 85 minutes. Okay, because 1 hour is 60 minutes, and 60 plus 25 is 85. Absolutely. So now, we know that we have to multiply by 40, then add 15. Okay, so if I take away 15 minutes, so 85 minus 15 is going to give me 70. So now, how am I going to find the weight of the chicken? I need to divide it by 40. So 70 divided by 40 is going to give me 1.75. So that means the chicken is 1.75 kgs. Part D says, use Francois' rules to write down a formula for the time in minutes to cook a chicken of weight k kilograms. Okay, so we know the time equals the weight of the chicken, which is told us is k, times 40, and we have to add 15. However, as we know, mathematicians are very innovative, a little bit lazy, so we're looking at the quickest way to write this. What we would actually write is t equals 40k, because we know that means 40 multiplied by k plus 15. And that is going to give you full marks. Okay. Question 8. In Berlin, a watch costs 120 euros. In Dubai, the same model of watch costs 600 dirhams. The currency exchange rates are: calculate the difference between the cost of the watch in Berlin and the cost of the same watch in Dubai. Give your answer in pounds. Correct 2 decimal places. Yes, we need to figure out pounds. So let's have a look. So let's start with Berlin. Right, in Berlin, we have it in euros. We know that £1 equals 1.16 euros. Okay, we have 120 euros, and we need to find it out in pounds. Now, there's lots of different ways to do this. My favourite way is, so this equals 120 euros. My favourite way is to think about, right now, how would I get to €1? How would I get to €1? Well, I would divide by 1.16. And then, how would I get to 120 euros? Well, of course, I'd multiply by 120. So I'm going to do the same thing here. What's 1 divided by 1.16? Okay, now this gives me an ugly decimal. I say ugly, it just goes on for ages. It's not really ugly, it's beautiful. So I'm going to leave it as a fraction, so 25 over 29. And then, what did I do? So I divided by 1.16, and I'm going to multiply by 120. Times 120, and I get 103.4482, etc., which is 103.49 to 2 decimal places. So that's in pounds. Okay, so we worked out in Berlin how much the watch cost. In Dubai, though, it costs 600 dirhams. So if we know that 1 dirham, okay, is 0.24 euros, how much is 600 dirham going to be? Well, we've had to multiply by 600, so what am I going to do on the other side? This is just like when we do ratios. That's all we're doing here is direct proportion. 0.24 times 600, we get 144 euros. Now, we already know that 144 euros is more expensive, okay? However, it wants us to still calculate. It wants the difference between them. So now we're going to do the same with the euros. If I need to find out pounds, I'm gonna go through this process again, where I know that I'm gonna have to divide by 1.16, and then multiply by 120. So to get to pounds now, not multiply 120. Sorry, what am I multiplying by? 144. Or I could do it the other way around. If I Okay, so I'm going to divide by 1.16. 144 divided 1.16 equals 124.137. 124.137. This is how much pounds it's going to cost, because now we're in pounds, aren't we? So now we have £124.14, 103.49. So now I need to find the difference. So 124.14 minus 103.49. And this is going to give me £20.65. Okay, £20.65. So that is the difference. Okay, question 9, bearings. So, the scale of the diagram shows the positions of a post office A and a police station B in town. Measure the bearing of B from A. Now, with bearings, if it says from A, it means we start at A. What do? We always start the north line and we go clockwise. The first thing I'm going to do is draw a straight line using my ruler between A and B. Here we go. So now that I've done that, I'm going to get my protractor, which I've lost, but I will find. Here it is. Okay, perfect. So now I'm going to get my protractor. Okay, I'm going to line it up. So remember, I'm going to start from north. I'm going to start zeros here. I'm going to go all the way around. And you can see here, this is about 107. Now, how do I know it's 107 instead of 87? It's because I started with it from north, 0. And you see I'm following the inside, 10, 20, 30, 40, 50. So I'm going to get 107. Okay, so that's 107 degrees. Now, also, I know that realistically, if you think about it, we all know that this is a right angle 90 degrees. So if my angle is going to be more than that, I know it's going to be more than 90 degrees. Okay, I have to, think about what's happening here. This is 107. Then it says the town hall is at position C. The bearing of A from C. Okay, so from C. So it means wherever C is, we've had to go 45 degrees. And let's face it, we know that that's at roughly this big of an angle. Okay, so wherever C is, we've had to go 45 degrees. So we could, in theory, C could technically be here, because roughly that's about 45 degrees. Okay, so it says calculate the bearing of C from A. So first of all, what do we know? We know if this is 45 degrees, because we have our north lines, these are technically parallel lines. So this means that these two angles here are co-interior and add up to 180. So this is going to be 135 degrees, okay? Now, what's the bearing of C from A? So it means we start at A and we go all the way round to C. So it wants this angle here. So I know this is 135. I know this is 107. I'm able to find this last angle because we know that angles around a point add up to 360 degrees. So I'm going to do 360 minus 107 minus 135. 360 minus 107 minus 135. 118 degrees. So I know that this is 118 degrees, so I can do 118 plus 107. which is 225 degrees. Okay, there's another way we could have done it. We could have just done 360 minus 135. Now, it's completely acceptable whichever way you do it, as long as you get the answer correct. So well done. Question 10. Here's a list of ingredients needed to make 24 currant buns. Gina wants to make 60. Okay, so let's think about it. If I've got 24 currant buns, if I double the recipe, what does that give me? 24, it's 48. Okay, from 48 to get to 60, I need to add 12, don't I? Which is half a recipe. So I need 2.5 lots of the recipe. So I can double check my maths by, is 24 times 2.5 60? And you can type that into your calculator and you find it is. Alternatively, you could always just do 60 divided by 24, and this will give you 2.5. It's really good though to figure out actually what we're doing here. So work out the weight of butter Gina needs. So she needs 100 grams of butter for 24. We know that 60 is 2.5 times that. So I'm going to multiply this by 2.5 and I'm going to get 250 grams of butter. Okay. Hans wants to make 30 currant buns. Okay, so let's think about 30 currant buns. 24, and then what do I need to add on to make 36? So this is a whole one, and what is 6 out of 24 in terms of, it's a quarter, so really I need 1.25 lots. Again, alternatively, you could do 30 divided by 24, and then you're going to get 5 over 4, which is 1.25, okay? So, I need 1.25 lots of the recipe now. It says find the percentage increase in the weight of butter needed to make 30 currant buns rather than 24. Well, I know if I've got a whole one plus a quarter, what increase is that? That's an increase of 25%. Now with this, there are many different methods. I always think the best method is to use common sense, actually figure out what's happening, but you know that we could do this mathematically as well. Okay, so the rest of this paper is now the beginning of the higher paper. So this is question 1 on the higher paper. So have a look at the higher paper 1 to continue with this. There is actually one question that's not on here, and I'll go through that now. So here we go. Question 13 is actually not on the higher paper, but we needed those extra 3 marks. So let's go ahead and solve this. 5 lots of 2x minus 3 equals 20. 5 times 2x is 10x. 5 times negative 3 is negative 15. This equals 20. So I'm now going to add 15 to both sides. So 10x equals 35. And then divide both sides by 10. So x equals 3.5. And you can see that we've shown every step of our working. Okay, so show clear algebraic working. So you can see we've expanded. We've added 15. Because obviously minus 15 plus 15 is 0, 20 plus 15 is 35, divided by 10, because 10x divided by 10 is going to leave me with 1x, and this is y. Okay, nice, easy, 3 marks. So if you would like to see the rest of the questions, please have a look at the higher paper of this, and then you will see how to complete the rest of the questions. Well done and good luck.